real world type problem and how it looks using law of sines to solve it. It says a pilot begins traveling 80 miles northwest. So that's what we're seeing in this triangle right here. This is 80 miles northwest. Okay. To avoid the storm, he makes a turn, then returns to his original location. So he makes a turn, and then he goes back to his original starting point. So a diagram of his flight course is to the left. That's what we're seeing here. Find the total distance of the flight. So that means we need to know the total distance of the flight. So here's that 80 miles. Then he went some distance to the left when he made this turn, and then he went another distance all the way back to his starting point. So ultimately, we're going to need to find both of these lengths of the triangle. So we're going to start out just like we were before. Let's label the starting point as A, then B, then C. Because I know I'm going to end up having to find these, let's go ahead and find this other angle in the triangle. I have two of them, and those two angles, 108 and 15, come up to 123. So that 123, you're going to take that from 180, and that gives you the 57. So 57 degrees here, so that I already have that labeled and I already know what that angle is. Okay, then let's go ahead and be sure that we have our lengths marked. So A is opposite of angle A, B is opposite of angle B, and C opposite of angle C. So now we have it all labeled, and we can start using the sine rule in order to figure this out. Just like in all the problems we've done up to this point, we're actually looking for lengths of the sides of the triangles. So that means I need to go ahead and be sure that I have the unknown length of either A or B in this numerator. So let's go ahead and put in A first. So A needs to be over the sine of A, and the only thing that we know both of is the length of C, which is 80 miles, and we know the angle of C because we just found it, which was 57. So let's go ahead and substitute those values in here. Sine of 15, because there is A, 15. Then I have the length of 80 miles. Then I have the sine of 57. So this is that cross multiply, and then we'll end up dividing. So A sine of 57 is equal to 80 sine of 15. So we're going to divide this out. So that comes up to 80 sine of 15 divided by the sine of 57. It's 24 point, and it's still in the tenths, so 24.7 is our length for A. 24.7, and that is in miles. So now we have that length for right here. Now we need to find the length of B. And so we're going to go ahead and say B over the sine of B. Remember, I said that we can only use two at a time. And we'll go ahead and use C because C was given. We know that there's no error in that. So C over sine of C. So B over the sine of 108 equals 80 over the sine of 57. So B times the sine of 57 is equal to 80 times the sine of 108. Once we divide this by the sine of 57, we find 80 sine 108 and then divide it by the sine of 57, I get 90.7. So 90.7 miles. Okay. So we have 80 miles here for C. We have 24.7 miles for A. And we have 90.7 miles for B. So basically the entire trip, we need to add all that together. 90.7, 24.7, and 80. We get the total distance of the flight, 195.4 miles. And this was, remember, only given a starting point. We were given that he went 80 miles and he took a turn, so we have a path. An angle was given, so if that angle was given, that's great. And there's also an angle down here that's given. Once he returned, that's the angle that was made. So an angle, side, and an angle, we were able to use the law of sines.